we got this circuit here, and we are charging this capacitor, and we're looking for the magnetic field within this particular loop at this time. And in order to do that, let's recall that when we're charging a capacitor, we're going to be getting a current running through there. That current is going to be that's the voltage divided by the total resistance. And then there is e to the negative t over RC. So that would be the current that would be charging up in that capacitor right here. At the same time, we also know that the current inside a capacitor is going to be equal to the displacement current as well. So the displacement current comes from the magnetic field equation when we have the 2 pi r naught. That's the circumference of this loop. That's usually equal to mu naught times the ID. That's the current. That's the displacement current. Now, displacement current is usually going to be epsilon naught times the time derivative of the electric flux. But yeah, these two things are equal to each other, so we can use this instead when we're charging the capacitor. Now all we have to do is just plug in the time and figure out what the current is there. We'll also have to realize that this is not going through the entire thing, so we have a portion of the ID, really. It's not 100% of this. In order to get that, we have to multiply pi r naught squared divided by pi r squared. Then we can divide this stuff over. So 2 pi r naught. And you will notice that these will cancel, so that we're just left with something like mu naught, and then ID, that would be the IC really, so I could put IC instead. But then there's going to be a R naught, and then there is the 2 pi r squared. And that's what the B is going to be equal to. So yeah, let's just try to plug in these numbers. I want to find IC first. And I think we actually have to find C before we find IC. So the capacitor is going to be equal to epsilon naught times the area divided by the distance between them. So that would be equal to 8.85 e to the negative 12. We're going to divide that by 4 millimeters. And then we still have to multiply it by the area, which is going to be pi times r squared, which is 5.9 centimeters squared. So the capacitor is 2.42 e to the 11 farads. That's what we're going to use in here. And we kind of want to calculate the current at this point. So we'll say the 4.8 is the max voltage divided by the resistance is 35. And that's to the 6 there. Then we're going to multiply that by the e to the negative. And this is the time, 260 microseconds there. And then we have divide that by R and C. R is 35, big ones. And then the C is, we just found, 2.42 and negative 11. There's just so many numbers to punch in here. So that's going to give us 1 e to the negative 7 amps. And then we can solve for this by plugging in these numbers. So we'll have the mu naught, that is 4 e to the negative 7. I'm just going to get rid of this pi for now. And then we're going to go IC, that's 1 e to the negative 7, times the R naught, that is going to be 3.3 to the negative 2. And we divide that by 2 times the R squared, which is big one, 5.9 negative 2 squared. And so we should get that B equals 1.9 e to the negative 13 Teslas. Crazy.